Yo, what up, fam? Let's get going on this Mod 7 quiz review. Let's do it. So here, an angle formed by two sides of a polygon and a common vertex. What they're trying to say here, so you can actually read it. What they're trying to say with these words is anytime you have any kind of polygon, I'm going to draw a pentagon here. So these guys here are all of your vertexes, and the angle formed by the two sides of the common vertex is on the inside of the polygon. So we're going to call that an interior angle. That's the letter E there. For this next one, we have that angle formed by two congruent sides of an isosceles triangle. So remember an isosceles triangle, when you're drawing these, I'll switch colors here for an isosceles triangle. Isosceles triangle have two sides that are the same, and the two sides that are the same end up pointing to the base angles. So these ones over here are called the base angles on the bottom here, and the one at the very top they call the vertex angle here at the top. So the angle formed by two congruent sides of an isosceles triangle, we're going to call that the vertex angle. The angle formed by one side of a polygon and the extension of an adjacent side. So if I were to like take one of these angles and extend it out and then make an angle, you can see it's on the outside or the exterior. So we're going to call that letter F. Over here, the two congruent sides of an isosceles triangle. Those guys are going to be these over here. We're going to call those the legs. That's letter A. And the two angles are called the base angles. We just did that. And then the bottom part of the triangle is connected to the base. So that's just going to be that letter B at the bottom. Beautiful. Let's move on to the next question. So they do give you these formulas here. I wrote them slightly differently in class. When I did it in class, I did write them like this, where I did 180 multiplied by n minus 2. It's exactly the same thing. You're just using the fancy word is the commutative property that says that they are, or not the communicative, what am I just saying? The commutative, there's no C in there, the commutative property where you can switch the two around, and the commutative property switches these two around. That gets the same thing, and S over N stands for the overall sum divided by N for 7 to 10. They're talking about those exteriors. Let's just see how we do the problem. So what is the sum of the interior angles? That's this formula right here. So we're going to be writing that S is equal to, and then N, that is N right there. So 16 minus 2 multiplied by 180. Remember when you're doing these, you want to do the subtraction first, or you can throw the entire thing into the calculator at the same time. So if you're like doing this by hand, you do 16 minus 2, which is 14 there, multiplied by 180. And if you were just using the calculator though, right from the get-go, you could just type it in exactly as it appears. You could ignore all that stuff. 16 minus 2 and then 180, like exactly like it appears, and it will tell you it's correctly 2520. Or you could have just done 14 times 180, and that also works. And it's degrees. Don't forget your degree symbol just in case your teacher requires it. What is the interior angle of a regular decagon? So remember that this guy here means 10 sides. So it only wants a single angle. So first we're going to have to use this formula here. And then after we use this formula, we're going to use the second formula to figure out the overall sum. Or you could just combine them into one like I did in my class for the single interior angle. For the single angle, we wrote that our interior angle formula was n minus 2, and then we did the 180, and then we divided it by n. But again, you could just figure out this and then divide by n. It doesn't really matter. I think I put the 180 in front in my class. I said that earlier. Whatever. The point is you're plugging in the 10 and going from there. So we're going to have our answer is going to be 10 minus 2 multiplied by 180 divided by 10. There are a couple of cute different tricks you could do in this question, but I really think the easiest is to use these calculators the school gives you in an intelligent way. So our final answer here is to be using the alpha button. So we're going to hit the alpha button, the y equals button, and then the enter button. And we have 10 minus 2, and then 180, and then a 10 on the bottom. And it turns out we get 144. Please note, if you wanted to use their formulas up here, we would have typed it in as 10 minus 2 and then the 180 afterwards. And then after that, we would have divided the answer by 10. So that would have been fine too. Regardless, we get 144. I think we're all done with that one. So quadrilateral has interior angles 45, 110, and 130. What is the measure of the fourth angle? So in order to figure out the measure of the fourth angle, we can either know the fact that quadrilaterals have 360 degrees because they have two triangles, two 180s, or we could just use the formula that was already here for us. So I'm just going to use the formula first. So our sum here is going to be 180 multiplied by 4 minus 2. And if you plug that into your calculator, you will get 360. Just like I said, all quadrilaterals have 360. They got two triangles in them. But here, one of the fourth angle is we're going to subtract the other three. So we're going to do 360 minus 45 minus 110 minus 130. Figure out what that answer is, 360. I'm using my calculator here. I'm cheating. Minus 45 minus 110. Oops. Minus 130. Other teachers might have said to add all the numbers up and then do subtraction. It doesn't really matter. You get the same answer either way. You get 75 degrees. All right, let's move on. We got a polygon has an interior angle sum of 3960. How many sides must the polygon have? So the idea is you're still using the same exact formula that we were using before, this s equals n minus 2 times 180, but they're giving you the sum in advance. So you're going to have 3960 is equal to n minus 2 times 180. Many students make the error of, that's not an error, but it makes your question longer, take longer, of doing the distributive property where you multiply by 180 first. You actually don't want to do that. You'd actually be more intelligent to divide both sides by 180 first. So that's what we're going to do. I usually don't show the work for it, but I will here just because. So, and you know what, in order to show the work, because you might be looking at it later after you filled it out, I want to write it down. So you can actually see it where I write the work out, where I divide by 180, I divide by 180, and I cancel them out there. There we go. And when we do that cancellation, we're going to go ahead and grab our calculator to actually do it. If I remember correctly, it's 22, 3960 divided by 180. 22 is correct. So we're going to have 22 is equal to n minus 2. Then I don't think I need to show the actual work for the last one. I think you can add 2 to both sides on your own. N is equal to 24. Let's move it. So the next one, what is the, we're going to be using different formulas, a nice little S over exterior angle. What is the exterior angle of a regular hexagon? So hexagon, remember that every single exterior angle, no matter what, always 360. And then the hexagon has 6. So this is just going to be 360 divided by 6. That's going to be 60 degrees. Easy enough. If the measure of exterior angle is 20 degrees, how many sides does it have? So we're going to be saying the sum, which is always 360 degrees, divide by the 20 degrees, and you're going to end up getting a nice solid, what is that, 18? I can do math, right? Yeah. Why am I second guessing myself? Of course it's 18. Okay. Get it together, Mr. Richards. All right, what is the measure of angle S? So a couple different ways to approach this one, but the easiest, in my opinion, is to remember the exterior angle theorem for triangles, which says that the exterior angle is always equal to the other two angles added together. So we can say that 7x is equal to, and we're doing 66 plus 3x plus 2. From there, we definitely want to move the 3x to the other side. So we're going to be subtracting the 3x from both sides. I'm not going to show the work for it. 7x minus 3x is 4x. 66 plus 2 is 68. And then we can divide both sides by 4. And if we divide both sides by 4 there, we get 17. Yeah, 17. So we get 17, but that's not the question. What it asks what the measure of angle S is. So we're going to have the measure of angle S. That is going to be 3 multiplied by the 17 plus 2. So our final answer there is, was that 51 plus 2, 53? 53 degrees. And then to find the measure of PQR, a couple different ways you could approach that. I think by far the easiest way is using our original formula up here. It must be these two angles added together. So we can just do 66 plus 53. You could also do 7 multiplied by x. So a couple different ways you could do it. I'll just write them all. So I can just say that it's 66 plus 53, and that's the same thing as 7 multiplied by our 17 that we found, regardless of what you get for your final answer. Let's see, 66 plus 53, and we can actually prove this by doing 7 times 17, and we get the same exact answer. Oh, you didn't even see what I typed in. Either way, you get 119. It does not matter. Both methods are acceptable. Let's go to the next page. So going on to the next page here, we have in this figure, what is the measure of angle R? So in this particular question, we have a couple different ways to approach it, but because we have these two different marks here, those two different marks means that the opposite sides, the sides opposite of them, so like going all the way across here, are identical. So in other words, this one right here is also a 3x plus 3, and that's going to help us set up an equation that lets us solve for x. So for this one, we're going to go ahead and do 3x plus 3 plus 3x plus 3 equal to 100. I messed up. I'm gonna run out of room. Okay, 3x plus 3 plus 3x plus 3. I forgot the 5x minus 2. Plus 5x minus 2 is equal to 180 degrees. So you got to add up all this one and this one and this one. You're adding them all up to get 180 total. I apologize for my bad handwriting, but yeah, you're doing this plus this plus this. So 3 plus 3 plus 5, that's 11. 3 plus 3 minus 2, that's going to be 4. I hope I didn't make a mistake. We'll find out. We're going to subtract 4 on both sides. We're going to divide both sides by 11 now. And what's that, 15? I really hope so. 176 divided by 11. Checking on my calculator. Oh, it's 16. Yikes, Mr. Richards. Of course, 1 times 6 is 6. I should have known. Anyways, we got 6. However, asks us for the measure of angle R. So we're going to go ahead and plug in that x in the end. So we have the measure of angle R is equal to 5 multiplied by 16 minus 2. That's going to be 80 minus 2 is 78. All right, let's do the next question. So here we have the measure of EF. So exactly the same, it is a measure, it's a length, the measure of EF. So in this one, we have these angles all being the same. If all the angles are the same, it means it's an equal lateral and equal angular triangle, which means all the sides are the same. So we can actually just set 10x plus 3 equal to 3x plus 24. And solve this equation, do our little switcheroo. I think it's going to be the easiest for us on this question. So subtract the 3x over, subtract the 3 over, and we're going to get 7x is equal to 21, and therefore x is equal to 3. You plug the 3 in where it wants that EF, so EF is equal to 3 times 3 plus 24, and that is 33. Yeah. All right, perfect. Let's keep on moving. So here it has in the figure, what is the measure of angle J? So same exact concepts as these other ones where we have our sides going across that must be the same. So if you want to think about it in terms of like a math equation, the math equation is like this would be an x, this would be an x, and you'd have 2x plus 58 has to be equal to 180. And you could solve that equation by subtracting 58 on both sides. 180 minus 58. Why am I using a calculator? I don't know, but x is equal to 61. And that is our correct answer. But the more standard way of teaching a question like this is instead to think about it as 180 minus the 58 and then dividing it by 2 kind of all together, because that is also another way of doing it. You have all the triangle, you're subtracting 58. These must be the same, so divide it in half. Regardless, 61 degrees is your final answer. I'm going to let you decide how to do it. Here we go. In ABC, what are the side measures in order from least to greatest? So the main concept on this question is that same one I was talking about before, where the side kind of goes with the opposite angle. So angle B goes with side AC. Because B is the smallest angle, AC is the shortest side. So again, B is the smallest angle, the letters it doesn't touch. So like this one here goes with the measure of angle B is the smallest, and then the next smallest angle is 68, so that's angle C, and it goes with the letters it doesn't touch, A and B. So AB is going to be our middle value there, and again, that's because our measure of angle C is in the middle, and you'll see it's the letter it's not there. So B is not an AC, C is not an AB. For the very last part of it, we have the A going across from it is 79, the BC, the last side we haven't talked about, the measure of angle A is the one we're thinking about. Either way, there's our correct answer. Let's move on to number 19. In triangle JKL, what are the angle measures in order from least to greatest? Exactly the same concept. So we're doing from least to greatest. So this number 10 kind of goes with this letter K going across. So the JL goes with the letter K. So we could write angle K is the smallest measure, and then the next smallest measure is going across from the 12, which is, going the KL, the letter that it doesn't touch, which is J. So then we have angle J, and last but not least, we're going to have angle L. Look at that, an angle and then an L. It looks like the same thing. These are all angle symbols. Angle, 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 by the way, just a heads up. All right, anyways, number 20. Which of the following measures can be the side lengths of a triangle? So remember, for all of these, you're really trying to double check which one of these where you have the two smallest. The small plus small 1 plus small 2 has to be bigger than the big one. So the two smallest must be bigger than the big one. So let's check this one. The first one, we're going to check 4 plus 9. Is that bigger than 14? Well, 13 bigger than 14. No, that is a falsehood. So that one's wrong. Let's check the next one. 7 plus 1. Is that greater than 8? Is 8 greater than 8? No. So this is another no. The next one is going to be 3 plus 4. Is that bigger than 9? No. I'm just going to say no again. Of course, 7 is not bigger than 9. The last one, though, is going to be a yes, because 6 plus 8 is in fact 14, which is bigger than 13. That's a check mark. That's a yes. Letter D is our correct answer. I'm done talking. Have a wonderful rest of your day and peace out.